Hey folks, welcome to Narratives. Narratives is a podcast exploring the ways in which the world is better than in the past, the ways it is worse, and the paths towards a better, more definite vision of the future. I'm your host, Will Jarvis, and I want to thank you for taking the time out of your day to listen to this episode. I hope you enjoy it. You can find show notes, transcripts, and videos at narrativespodcast.com. Well, Trevor, how are you doing tonight?
I am doing well. How are you doing?
Doing good, doing good. Thank you so much for taking the time to hop on with me. I really appreciate it. Um, Before we hop into some of the questions I have, do you mind giving kind of a brief bio and some of the big things you're interested in?
Yeah, sure. So my name's Trevor Klee. I'm a Boston, Massachusetts. Have two very disparate job titles right now. So I currently both run a small education business doing test prep, sell books. I have an app, tutor people, have YouTube videos. So that's one thing that I do. And then I'm simultaneously trying to get a pharmaceutical startup off the ground. Um, Looking to do a therapeutic for autoimmune and neurodegenerative diseases. So it's maybe one of the stranger side hustles that people tend to have. Hopefully, it's soon a full-time hustle.
That's
Uh,
awesome.
yeah, I'm interested in stuff relating to both of those.
Gotcha. Do they sound disparate, but do you see those two as connected in any way? Or is it something,
Um,
test prep has been paying the bills and you want to, this is what you've been thinking about for a while, this pharma.
yeah, so they're not particularly connected. I would say like the people in the test prep world who I talk to, literally none of them have any interest in this. And vice versa for pharma. So there's little to no connection. The closest connection I actually can make is I taught philosophy for like a year and a half to like Chinese college students as sort of like a strange job that I had. And that sort of got me down the process of like more researching on my own after college. And I think that was the closer to connection to this pharma stuff. But again, it's a very weak connection. I can't make a very strong claim as to how exactly I became interested in these two things.
That's awesome. That's awesome. And do you have a bio background at all? Or are you just like something, you've done a lot of reading, you found some interesting areas and perhaps found a $20 bill on the sidewalk that people have missed?
Yeah. So I in college I did research into earth sciences. I did research into climate change and hurricanes specifically. And then yeah, no, that was pretty much it for the scientific background. I took one molecular biology class in college, and everything else since then has been self-taught. I will say, my brother has his own pharma startup, which is actually much further along than mine. They're just submitted an application for drug approval to the FDA, actually, which is
Oh,
like,
awesome. It's a big
many
deal.
years and millions of dollars down the line. Yeah, it's a big deal. It's very exciting. So I've, spent a long time talking with him and his business partner about these sorts of things. So it wasn't entirely foreign to me. I saw him go through it, but of course it's really different when to go through it yourself.
No doubt. No doubt. That's really cool. Um, First question, test prep. Um, you know, I'm curious, and we can absolutely cut this if you want to.
Yeah.
But for my own curiosity, I've always envisioned a lot of these standardized tests as kind of like fairly pure test of cognitive ability. Can you get better at them if you get more familiar with them?
Oh, completely. Yeah. The idea that you can't is a lie spread by the test prep companies because
Oh,
they
yeah.
want to be pure tests of cognitive ability. I mean, it's like chess, where you start from and how fast you learn has something to do with cognitive ability. But like, a total idiot who spent 5 years studying chess intensively is going to beat a genius who's never played chess before. I mean, there's a lot of crystallized knowledge that goes into it.
Gotcha.
And that's, same thing with these tests. Smart people will have an advantage coming into it, and they'll have an advantage if they study, but there's so much crystallized knowledge that goes into it.
Gotcha. That's super interesting. And are some tests, more prone to that than others? Like, are some is there anything like that you found?
So the biggest distinction between tests, which is generally a distinction between subjects that people don't pay enough attention to, is skills versus content.
Okay.
So, two of the tests I teach are like the MCAT and the LSAT.
Yeah.
LSAT to go to law school, MCAT to go to medical school. The LSAT is purely skill-based. Like, you can go into it and score presumably even a perfect score, never having taken it before, if you think about it the right way.
Gotcha.
Meanwhile, the MCAT is heavily content-based. Like, I usually tell people they're going to study for around 300 hours before they ever are ready to take a practice test.
Oh, wow.
It's a ton of content. It's a huge amount. And so that's the single biggest difference, and the way you need to approach it really changes pretty dramatically. Which is why, there's a lot of people who are smart at math, but dumb at history, or vice versa. It's a question of skills versus content.
Gotcha. That's super interesting. And how has it been developing the tutoring business over time? Has it been something where, you thought this would be a fun thing to do and you got into it, or was it just like a kind of emergent thing where, maybe you helped one person and then it kind of took over because you're pretty good at
it? It became a thing. Like, I was unemployed after college, and I think pretty quickly realized that I'm probably not employable. As someone who hasn't had who had very few traditional jobs in my life, and sort of stopped having traditional jobs 6 months after college, I got fired from a lot of jobs, either fired or not asked back. So I think I needed something that would pay my rent, and this was something that I enjoyed and was good at. But yeah, no, from the very beginning, it was like, wow, I really need to pay rent.
Right. It's like a hard need. That's super interesting. I wanted to shift gears a little bit. Why do big species tend to live longer than smaller species? And why doesn't this carry over to dog breeds?
I don't understand how that's a shift in gears at all. That goes directly, direct segue.
Yeah, exactly.
Yeah, so this was the subject of the blog post, Eric. So the start of the blog post was sort of this, I always like starting things with sort of simple observations. And that's I think in general, the way I view a lot of bio is there's so much of it we don't know. And I think it's most interesting to start with a weird observation and be like, huh, that's neat. And then you explore and you say, why? So this sort of weird observation I started with is, between species, bigger species live longer than smaller species. Elephants live longer than mice. Whales will live longer than dolphins. That's pretty much universal. There are rare exceptions, right? Like humans live exceptionally long, naked mole rats live exceptionally long, bats live exceptionally long, compared to their size.
Right.
But generally speaking, that's the pattern. And now within a species, that's not true. Bigger species of horse, given a single horse, a bigger variety is going to live less long than a smaller variety. A Chihuahua is going to live longer than a Saint Bernard. Great Danes are sort of famously they're heartbreak dogs. They live till they're 7 years old. So you've got this question of why, does an elephant live longer than a mouse, but a Saint Bernard live shorter than a Chihuahua? So that was sort of my initial question. And I found a lot of really unsatisfactory answers to it. there's one like weirdly common answer that's like number of heartbeats. Like
So
we all
God,
have a certain number
it's
of
like Buzz
heartbeats.
Aldrin, like you've only got a certain amount, and once you've
Yeah,
burn them all out, you're done.
yeah. Yeah, I remember there was like a Dilbert comic at some point where they like I think Dilbert was arguing that like he only gets 1 million heartbeats, so he shouldn't exercise because he
Right,
would
exactly.
use up more of them.
Yeah.
So so yeah, so I was really unsatisfied with the answers I found. I thought it was easier to explain why a Saint Bernard would live less long than a Chihuahua, which is just mainly mechanical stress on heart,
Right.
lungs. There's more body surface, there's more chance to get infections. There's more chance for cancer when you have more cells. So that made sense. The question was then, why do elephants live longer than mice? And so you can answer it from two perspectives. One, you can answer it from an evolutionary perspective. You can say, why do elephants live longer than mice? It's because the evolutionary strategy of the mouse is have lots of kids very quickly, sort of like, spend all of your evolutionary energy in like 2 years, just have like the really rapid generation. And, elephants are case selected, as they call it, let's have one kid every once in a while and put a ton of energy into that kid.
Right.
But that doesn't really explain the how. There's not really a mechanical answer. So mechanically, it came down, and this is where it gets a little fuzzier, but mechanically, I believe it comes down to the immune system. And that's, the immune system, as you can probably tell, is something that I find super interesting. I've come back to it in various forms, like again and again. Mainly, sorry about that. My dog is playing with a bone. The immune system, the way I described it in an earlier blog post was like it's coming in at like series 3 or like season 3 million of a show. Like season 3 million of a show that was like already complicated to begin with, because there's just been evolution, and everything's so intense and evolving so quickly. So the immune system is this super complicated, intricate defense system. Now, what does that have to do with elephants and mice? Well, if you think of a mouse's immune system is not designed to make the mouse live long. It's pretty much just like anything that could throw it off course for that year or two, which is pretty much just going to be infections. It doesn't care about cancer because it's probably not going to live long enough to get cancer, right? It's really just like cannot get infected for that year or two, like, and then so whatever happens, like anything that remotely looks like an infection, it's going to blast it away. As a result, it's going to cause a lot of collateral damage, right? Like imagine if your police force, not to get political, imagine if your police force had this job that was like, shoot anything that looks suspicious.
Yeah.
You would probably kill all the criminals, and you'd also kill a lot of other people.
Right.
Which again, not going to make any sort of political commentary about that. Now, meanwhile, if you think of an elephant's immune system has the job, first of all, of like, it can't be that aggressive, right? It can't shoot anything that looks remotely threatening because you're going to kill a lot of things. And it also has the added problem of an elephant lives long enough to get cancer. And like cancer is much more complicated and much harder to deal with. And your immune system has to be a lot more clever to deal with it, because it is essentially your own body cells.
Right.
So, essentially in bigger species, the immune system through, preference of like sort of like the adaptive immune system of neutrophils, of parts of the immune system that are more selective, that tends to be preferred in bigger species and in species that live longer. And in species that live less long, you tend to have more of, like, for example, NK cells, which are sort of infamously aggressive. They're called natural killer cells because they will like kill anything. And that's what they do. And we have some amount in our body, but if you look at like a mouse, proportionally, they have way more. So, they have so many NK cells that are on the lookout for literally anything that it doesn't know for a fact is benign. The NK cells will kill it, which is really interesting. If you take a look at like bats lack NK cells. So bats live like 20 years. If you think of a bat as a flying mouse lives 1 or 2 years. A bat lives 20 years. Bats totally lack NK cells. So it's a really interesting thing. And then you can start thinking about other ways. Okay, what does this mean for human longevity? And there's stuff relating to the immune system that we could go into for human longevity, but that's another step. Anyways, long story short.
That's super interesting. Yeah, we talked to before everything went down with Aubrey DeGray. We talked to him about opossums, and we got a lot of possums in North Carolina. There's an island in North Carolina off the coast where the possums live, twice as long. They live like 3 years instead of 1 year, 1.5 years on average. And that's because they have no natural predators. So it's like, what kind of switch do they have, right? Where you can you kind of make that multiplier. It has something to do with the immune system. It's quite interesting. Super interesting.
Yeah. I mean, I don't know much of Aubrey DeGray's work specifically. I know that crew tends to be really big on rapamycin, which is, an immunosuppressant. Like caloric restriction, has a lot of effects, but immunosuppression is one effect of caloric restriction. So there's really interesting stuff going on there, in terms of what the relation is, and ultimately, how can we, quote unquote, hack it to extend our own longevity.
No doubt. Are there any you mentioned bat immune systems? Is there anything unique about bat immune system that lends them to create, incubation of certain, viruses or anything like that are particularly pernicious to humans?
Excellent question. The quality of questions just, yeah. That happens to be another thing that I have a long-winded explanation about. So bats are weird. So we keep getting viruses from bats, and we get viruses from bats way more often than you would expect, right? Like, yes, people sometimes eat bats. Yes, they sort of live in our like cities, but we get viruses from bats way more than we get viruses from, rats, which are in much closer context, or right. Cats or pigs. Like a lot of things that we should be getting viruses more from. Coronavirus is just one example. There's, a couple different viruses which, bats are natural reservoirs for. So it's weird, right? Like, why bats? And so one answer is bats have similar immune systems to us, or similar enough. It's the similarity of immune system depends on a lot of different things. But pigs do have closer immune systems to us than bats. Fish have further immune systems. So it's not a great answer. So it starts getting to the point of what's different about bats. And so the short answer is what's different about bats is bats are dirty, dirty creatures. They are infected with viruses. They're not just reservoirs for human viruses, they're reservoirs for all sorts of viruses. And it's weird because you'd expect them to all be dead. Like, why are they all dead? And so the answer seems to be that the reason why bats aren't all dead is bats naturally, they're a flying mammal, which is a hard thing to do. It's hard to fly. It's really energy intensive. And that means that bats get their core temperature raised. And so what that means for bats is, first of all, they're always kind of running a fever. So that's going to help somewhat. Now, the other thing that's going on with bats that's different than, other mammals is, as I mentioned before, bats have a weird immune system that probably has to relate to the fact that they're always running a fever. And what happens when you're always running a fever is you're always sort of damaging cells. And you're getting weird. Now, you have to understand that, like, there's only so many building blocks of things in your body, and your body recognizes an enormous number of cells. But if it sees malformed cells or malformed DNA or malformed RNA, it's usually going to kill it. like that's something that happens, a lot in, you get like necrosis from like a sunburn or something like that. Your body, your DNA gets damaged and your body's like, well, we got to kill this. I
Get
don't
rid of
know
it.
what it is. It might be cancer, kill it, get rid of it. Bats can't afford to do that because then they would just die. So their immune system has essentially adapted to be sort of on a constant state of low alert, where, their immune system is active enough that they don't die from these infections, but it's not so active that it kills all the cells that are being damaged from their constant low grade fever.
Gotcha.
And what that means for bats is that bats, are constantly a little sick. Like
Gotcha.
bats constantly have the sniffles, which works for them and doesn't work for us because, we come in contact with them and it's just they're, we're not like them. They have, coronaviruses, which to them are the sniffles, and to us, we get them and we end up dying. But
Got it. So is it something where, like, because you've got this constant kind of source of damage, is there more mutation of like coronavirus or something like that? So there's more novelty that can come from bats.
I
And
mean,
that
so
may
the
be an ignorant question, but I don't know.
So I mean, I don't think coronaviruses need any like encouragement to mutate. Like, they're gonna mutate regardless. Viruses mutate constantly. If I recall correctly, the coronavirus especially, I think mutates a lot. I think it has poor error checking. But the more important thing about bats is that they're very, very social. They live in
Gotcha.
massive groups. Um, so it is like a natural testing pool. So anytime a virus has the chance to mutate, right? Like if you think about, I sort of think about it as like capitalism, right? Like, every virus is like selling something, right? And
Yeah.
whoever manages to come up with a slightly better advertisement or maybe a slightly better product, right? Like it can spread across a million bats instantly. So that's, there's high evolutionary pressure in terms of there's lots of chances
Got it.
to like, hit it big. That's why, to get to the commerce example, why you see a lot more experimentation and sort of like novel business ideas in New York City versus, Wichita.
Makes sense. Super interesting. That's super interesting. Um, Sticking on the immune system, people talk a lot about inflammation, but what is inflammation, and why does it matter for the immune system?
So this is a great question. This is one that I got in an argument with people on Reddit about.
Nice.
So I started off like, inflammation is something I think about a lot, mainly because I don't think I really dislike the way it's usually thought about. Like a lot of stuff about, oh, we need to reduce inflammation. That's like a very classic thing you'll see in medicine. You'll see like, people will say, oh, Advil is good because it reduces inflammation, which is actually an interesting thing. In the US, doctors will say, if you're sick, take Advil, it reduces inflammation.
Yeah.
In continental Europe, if you're sick, they'll say, well, actually, inflammation is a good thing. Don't reduce inflammation, don't take Advil. So that was actually in the beginning of COVID, there's a big argument of like, do you give COVID patients Advil? Where the Americans were like, of course, they have a fever, and the Europeans were like, no, don't do it, they have a fever. So, this question of inflammation, I think is a really interesting one. And part of the problem is, we only have so many pathways in our body, right? And inflammation is this really common pathway of if you get an infection or if you get a pimple or if you sprain your ankle or, whatever, you end up with this like swollen, red, hot to the touch, right?
Yeah.
So it's a super common pathway for a lot of things. It's sort of like an initial alarm. So, in terms of what's the point of inflammation in the immune system, it's tough. The answer has to be it's important and it's vital and it's necessary. On the other hand, if you look at some of the like leading biologics, like Just forgot the name. The one it's TNF alpha. It's like the top selling biologic. I'm forgetting the name right now. Um, but like, things that people take for arthritis or Crohn's or whatever can almost completely disable inflammation. And there doesn't seem to be the crazy negative effects that you would expect.
Interesting.
So there's something going on there. And that's actually, I mean, it's a continual source of, do you know what a biologic is?
Conceptually, but not well enough. Can you explain it to me?
Yeah, yeah. So biologic, so basically, there's two main drug categories that you can have. One is a drug that's like you take from the outside world, and another is a drug that is designed to mimic something in the body. And very broad categories, and someone's going to argue with me about that. So a biologic is meant to mimic something in the body, and like the most common and the best-selling ones are monoclonal antibodies. Antibodies kill things, so we can make your body kill basically anything else in your body. So like stuff, autoimmune diseases, rheumatoid arthritis, we can have your body kill the things that would attack your joints. The other, big selling category, of course, is insulin, which is a whole nother thing. But again, like we're trying to mimic insulin, which is something your body naturally produces, or it's at least supposed to. So, a lot of these biologics do reduce inflammation incredibly well. And you do see some rise in cancer and some rise in infection. So a healthy person definitely should not take these, but it's still remarkable. And maybe just as a result of like the super hygienic environments we live in, that like your Nana can take her, weekly injection of Humira, that's what it's called,
Yeah.
of Humira for rheumatoid arthritis, and she doesn't drop dead of pneumonia. It's an interesting question for me, and one that I think is not as well explored as I would want or expect.
Yeah. Well, that's super interesting. Well, it's like going off of that, there's this great debate in sports medicine whether or not you should ice, or provide heat, like to, you sprain your ankle. Like, it's a great question, right?
Yeah, I've gone down that one myself. I do jujitsu pretty regularly, and I'm constantly injured. In fact, I currently have a case of cauliflower ear from jujitsu.
Oh no.
So questions of icing and resting and compression and elevation is one that I think about a lot. And honestly, I do nothing for my injuries, so I'm probably not the right person to ask, but I do think about doing stuff for my injuries.
Super cool. Building a small biotech, what have been the biggest challenges, and how is the FDA, how is FDA, how do you see it as a small biotech? Is it just completely horrifying, I'm assuming?
Yeah. So the thing about being small biotech is, first of all, like, I've had a lot of, I've had various businesses, some more successful than others, of like service business versus software business versus like, sort of like a product business or info product business. And like the thing about biotech is you can be small for only so long, right? So like when we talk about small biotech, like at the end of the day, the smallest you're going to be is, a couple hundred people and like 30 million or like 90 million dollars in funding. Yeah, at least 100 million in funding. Like there's only so small you can be. So
very capital intensive.
Oh geez. Very capital intensive, very people intensive. It's so small biotech is, we always got to be aware of what we're talking about. Now, from the perspective of someone of a company though, that's not Pfizer, that's not Regeneron, it's not, Merck. Basically, what is the FDA like from the perspective of people who don't know people at the FDA? Which that's sort of, when you submit to the FDA, does the person in reading like your submission be like, oh, hey, it's those guys?
Oh, it's Trevor.
Yeah. Oh, hey, what's up? Yeah. And that's sort of with any regulator, that's a big advantage. The FDA, I think, and granted, I haven't dealt with that many regulators, but the FDA, from my perspective, is uniquely scary to deal with if you don't know people there, or, at least if you don't have name recognition. And I think there's very little oversight of the FDA. So the FDA is divided up into divisions.
Yeah.
And the FDA has this very they're biased against approving things. And I mean that in the most literal sense of how they're organized. They have steps of organization, and you have to make it past each step. So at any point, the people can say, you can submit it to the division, and the division can say no. They say yes, it goes one level up, and those people can say no. Or they can say yes, and then it goes one level up, and then they have to say yes. So you basically have to get 3 yeses to go. And only, the no's can also generally sink you. So it's a problem, because there's unique tiny fiefdoms, and you can really end up getting screwed. So there's a story recently of this biotech called Axome. And they're doing for something for major depressive disorder, combination therapy, bupropion, dextromethorphan, which it's not a brilliant combination. It's like an antidepressant and another thing that looks like a rapid antidepressant, but it seemed to have an effect in major depressive disorder. And they had sort of this terrible experience, which, I haven't checked recently. I don't even know if it's resolved yet. They were all set to launch. They hired all their people. They're, ready to advertise. Good to go. Good to go. And the FDA sends them this letter on July 20th. And the letter basically just says, wait. It doesn't say anything else. It just says, wait. We'll let you know in 3 weeks.
Brutal. Yeah.
Yeah, which is it's brutal, right? So Axome, they don't know what to do. They have to issue, their publicly traded company, they have to issue a press release saying the FDA told us to wait. We have no idea what they want us to wait for.
Stock craters.
Yeah, literally halves in a day.
Yikes.
And then 3 weeks later, the FDA sends them another letter, and all that letter says, or actually they didn't even send them a letter. They told them this in a phone call. They said, we don't need any additional information from you. They didn't say stop waiting. They still want them to wait. They just said, we don't need any additional information, which you can read as 2 ways. One is them saying okay, at least we don't have to run another trial or something like that. Or you can think of it as oh, I'm so screwed. The FDA doesn't even care. They don't even need any more information. They're ready to screw me. So it's and that sort of thing happens. I don't even know if that's been resolved yet. But that's just one case of it's just 1 or 2 guys at the FDA, and they can just put a total halt to things, and they don't have to provide a reason. They don't have to tell you why or why you're waiting or anything, and they can just do it indefinitely. You can't stop them. So it's really tough, and you're not. I think people misunderstand what it's like. You can't sell anything. You can't do anything, right? Everything flows through them.
Yeah.
And the FDA declares jurisdiction over pretty much everything. What's on your website is the jurisdiction of the FDA.
Yikes.
Your marketing materials is the jurisdiction of the FDA. What goes on in your factory is the jurisdiction of the FDA. Every single part of your company is their jurisdiction. And any single part of it, they can tell you to change, or that they don't like it. Or, they can just say they can sort of go for the nuclear option. They can say, you're done, right? You can be 10 years in, $100 million in, and the FDA can say, no, you're done. It's a tough business. Now, why is this the business I'm going into? Good question.
Do you think you can have an outsized impact, I guess?
I mean, I was being a little flippant. In terms of things I like things I enjoy. I really enjoy talking about this stuff, as you can probably tell. And as some kind of utilitarian, in terms of sort of like the biggest impact on lives, on happiness. It's a big deal. That's a big reason why I'm doing it.
Yeah, definitely. And it feels brutally underserved because of the regulatory hurdles, right? People, it's much, a software business, enterprise SaaS costs like $100,000 and to get up and running, and you could be selling after that. And that's a big multiplier versus 100 million. You know what I mean?
Yeah. I mean, it's so different, but in terms of, then you think about in terms of the effects on humans' lives. If I made another like CRM, like
right.
like I don't know. I mean, it might be nice, but it's hard to be like, oh my god, another CRM really.
You're definitely moving humanity forward.
Yeah,
100%.
yeah.
Yeah.
You ever watch Silicon Valley? Making the world a better place.
Yeah.
Yeah.
Exactly. Super interesting. Do you have any advice for anyone, working on a small biotech? You've been on this journey. I mean, how long have you been on the journey? And is there any big advice that, perhaps is non-obvious that comes to mind?
Oh, there's so much advice. In terms of how long I've been on the journey. So formally incorporated in early this year. So it hasn't been that long. I've been thinking about it for longer, and then but yeah, in terms of advice, so I want to go for very non-obvious advice.
Yeah.
In terms of so in terms of my most non-obvious advice for someone who'd be interested in this, it's I think animal studies don't mean anything would be my biggest
interesting.
advice.
Interesting.
I think the most common trap that people get caught in is they come up with these animal models, and they do all these things to these animals, and then they test out their drug on the animals, and then it works on the animals, and then they're like, all right, and then they're surprised that no one takes them seriously, because generally people don't, unless you've done something really surprising. And so my general advice is just, if you can, just skip the animals. I wouldn't say I got lucky. I looked for this on purpose. I found evidence in humans before I picked my drug combination.
Gotcha.
I think you can make a really clever in vitro model if you have really good reasoning as to why. But I think that's sort of my biggest example. I'll give you sort of the perfect example of this was, for the drug that I'm using right now, or sort of exploring right now. So cyclosporin is the main ingredient. Cyclosporin is an immunosuppressant with neuroprotective properties. So it's an interesting drug. And probably a decade ago, maybe 2 decades ago, people wasted years and millions on it as a concussion drug.
Oh, really?
The reason they did that is because they had animal models. And the animal model was essentially, what it came down to it is, you give a pig cyclosporin and then you hit it really hard in the head. Then you're like, what happens to the pig? How's he do?
Yeah.
First of all, these poor pigs.
Jesus Christ. Yeah. Oh God.
It's just it's an entire lab of people just finding
got a hammer. That's terrible. Jesus Christ.
Yeah. They're it's an entire lab full of people just hammering pigs in the head.
Yikes.
Which is but the other problem is, they were so proud of this model that I'm sure they had this really complicated setup that they didn't stop to think what relation does that have with humans?
Yeah.
The answer is, it really doesn't, because the way humans get concussions is not, you can't tell people to take a pill before you get a concussion, because a concussion is not something you expect.
Yeah.
So, the way humans get concussions is, we get a concussion, and then 3 hours later, someone's like, oh, I think you have a concussion, you should go to the doctor.
Yeah.
And so that's what happens. Or you get in a car accident and the ambulance rushes you to the hospital and you have a concussion and also like broken ribs and a bunch of other things wrong.
Yeah.
And so humans just don't get concussions like that. And the trial failed because you can't administer the drug like that.
Should have given
So
it to the NFL running backs. I mean, perfect.
yeah, I mean,
Very wise.
yeah, I mean, that actually, there's a guy now in Boston who's trying to like, who's really trying to do a concussion pill, who's trying actually to do this whole thing of like, what if we made these NFL players like take a pill every single time they got in the field, which I think is kind of nuts. I don't think you can do that because the standard for giving drugs to healthy people is like super high. And so if you have any side effects, they won't let you do that. But yeah, if I have any advice to small biotechs, especially like, the majority of them aren't going to be like me. It's very, very rare. Like my brother and I are like on a short list of people who've done this completely outside of any like cocoon of academia or industry. So most of these people are going to be in academia. I'd say ditch the animal models, either convince me with a really clever in vitro model or like somehow get inhuman data, which I know is a difficult prospect, but like figure it out.
That's super smart. Well, and I think that's why it sounds like what you're saying is people underrate how different animals are from humans, perhaps,
Yeah,
when thinking about these things.
like you come up with a really clever model and you fall in love with it and like you get more interested in solving the map than the territory.
Gotcha.
So like there's this model of heart attacks which essentially involves tying sutures around the aortic valve of a heart, and people do this with mice, and I actually researched a bunch of these when I was interested in the topic. And like there's paper after paper of how you suture the aortic valve of a mouse, which is really complicated. It's really hard.
It sounds like
tiny
terrible.
mouse, and you have to like perform some very complex surgery.
Yes.
And like the problem is you get so far down that rabbit hole, you don't think like, at the end of the day, this has nothing to do with a heart attack. Like at no point in a heart attack does someone like, you don't get your valve sutured. So I think people just fall in love with their very clever maps and they forget about the territory, or they think the map is a lot easier to deal with than the territory. So then they only deal with the map.
Yeah. That's really well put. I do wonder, do you think you and your brother being kind of outside academia, which is where all life sciences happens, except for, you two, I mean, literally it's probably you two, right? Like that's the list. Do you think that gives you just a better incentive model, to find things that are true, because you're not trying to optimize on publications, you're trying to optimize on like solving some kind of problem?
I would say, I think, and I have to give credit to him and his business partner, Josh, because, they were doing this, back in 2013, and I'm just starting to do it now. I think it really is a difference between what we optimize for.
Okay.
I think we're very concerned about like, how do you get this drug into patients? Like, let's get a drug that works on patients and get it into patients. And I think that's something that when I put it that way, to me, it seems so obvious. And then like these academic people will spend years messing around in their research projects, and like they won't even have a plan to get into patients. They'll be like 15 years into a research project where they're like, the top line of their website is like, oh, curing Alzheimer's or whatever. And they've spent like 15 years like messing around with like stupid research projects. Like, do you guys care about getting this in humans? Like what's going on? So yeah, I think it's really a difference in like, what are you going for? Like, are you just aiming to like fund your science projects in perpetuity, or do you actually want to cure people?
Right. And that's almost like a weird thing to say, right? But it does seem to be very true.
Yeah. Oh, it's like, it's insane to me the number of like, and they're winning at some sort of game. Like
right. Yeah.
It's insane to me the number of them that get like $50 million and can hire a whole crew, and then that's it. That's all they wanted to do. And they told their investors they wanted to cure cancer, and they really just never cared. They just thought it was really neat to, like, I don't know, genetically engineer viruses to do weird things. And they told their investors it was cancer, but it was actually just, I don't know, other stuff.
Seems just like project.
Yeah, it's a fun project, you know.
Very interesting. Very interesting. So I got one more line of questioning for you. You know, what's the best learning environment for humans? Any actionable stuff you found that you think people should apply?
Depends what you're trying to learn. I think the most important thing is, when I think about learning, I think of, like, I always tell my students there's a loop in learning. And the loop is, you try something, you get it wrong, you realize that you got it wrong, and then you apply it to the, like, you know, next similar thing. And I think that loop is, for pretty much any skill, is important. And I think how you change your environment, like, you need to structure your environment so you can get things wrong, you know, when you got things wrong, and then you can apply it to the next thing. So gotcha. Like, which is hard to do. So I'll give you an example. I learned French in high school, and my French is meh. I have a friend who's like, language learns as a hobby. And at one point he had like 7 or 8 languages he was actively learning.
Oh, wow.
And he was incredible at them. And part of it was he did what you would expect and studied. And, you know, he would study grammar and study vocab and whatever. But another part of it that he did that I never managed is he failed constantly. He would go up to strangers and talk to them in their language. And, you know, he would do this in languages he didn't speak very well, like Russian. Like, he traveled around Eastern Europe using Russian, and, like, his Russian at that point was worse than my French. I would not feel confident. Like I would be a little scared going around, like, you know, even France, never mind, like, I don't know, Francophone Africa, I guess would be an analogy, like trying just to get around in French with people who cannot speak English. He's fine with that. He's fearless. And, like, you know, he starts off looking really dumb because he makes really dumb language learning mistakes. But, like, you know, he receives that constant feedback, and he iterates and he iterates. And by the end of it, I mean, I've seen it happen. He learns languages much better than people who've been studying it for years, just because he fails constantly and he's constantly fixing it. So I think that analogy of, like, okay, what am I doing? Like, I'm going to get things wrong, I'm going to fix it, I'm going to then apply it to the next person, action, whatever, I think is the ideal learning environment.
Gotcha. So it's some sense in that you need to get fast feedback, and you need to just keep iterating on things to really make good progress.
Exactly. You need to fail fast and iterate fast. So if you're learning a language, you need to constantly be, like, looking like an idiot by using the wrong word.
Right.
If you're learning jujitsu, because that's something I think about a lot.
Yeah.
You need to be trying a certain move a lot, and you need to figure out all the ways the move can go wrong, so you can finally, like, come up with, okay, here's how this move works in every situation that I'd want to use it in.
Right. And it almost seems like if you're not, you know, if you're not failing enough, you're not pushing far enough. That makes sense. So you're not, like, getting out of, like, if you're just doing the jujitsu moves, you know, like, you would never fail. But, you know, if you're not pushing over the edge a little bit, you're not optimized enough. No.
So that's one big issue. Another big issue is just people don't recognize when they fail in certain.
Oh, they just don't even know.
Like, you know, and that's sort of like, you know, I think about jujitsu versus other martial arts. In jujitsu, you will know if you do a move wrong at some point, because at some point, you know, we constantly do competitions.
Yeah.
And, like, at some point, you're going to get in a competition, you're going to try that move, and someone's just going to, like, smack your face into the mat.
It's not going to work.
You know, and it's like, oh, this move does not work. If you do, like, I don't know, like traditional Kung Fu, and you never spar, you will never know you did it wrong, because no one's ever going to, like, you know, no one's ever going to smack you. Right. Like, right. And you can, like, think your entire life, oh, I have this really sweet move. And, like, you know, I guess one day, you probably never figured out. One day you're going to get a street fight and you're going to try it. And then, like, it's just going to be some idiot's going to clock you. But, you know.
No doubt, no doubt. That's a great. I love that analogy. One more big question. How can we teach calculus in a more robust way? And are there any lessons we can learn from that and apply elsewhere?
Ah, calculus, my greatest weakness. Yeah. So in terms of calculus, I think this was something I was thinking about. Like, I have lots of problems with how I was taught in school, which I guess maybe I don't know if that drives my interest in education or my education, or vice versa. I started getting really interested in teaching, and then I was like, wait, shit, why was my teaching in school so shit? So I think for calculus and for biology and for lots of things, I think the biggest problem we have when we teach kids is that they never love it and they never learn to love it. And the reason they never learn to love it is they never find it surprising or interesting. So like I said, I always start my biology essays with, that's weird.
Right.
You can start a calculus course the same thing, the same way. I mean, the way calculus was originally discovered, a lot of it was like, these European, mathematicians / scientists, natural philosophers as they call themselves, were obsessed with astronomy, and they kept seeing weird things with astronomy, and they come up with, that's why you had simultaneous physics and calculus at the same time, because like a big part of it was just, they were constantly looking in the night sky. That was something they really cared about. And they were constantly thinking like, how do I explain this? This is weird. How do I explain this? How do I model this? How do I predict this? And I think starting with that and then being like, this is why anyone would give a shit is very important. And I think instead in calculus or in many other things, we learn it as like, here's like God's given truths that you have to learn. Like it's, the Bible.
Right.
And like, you don't get to learn, like you learn calculus, and then if you're an engineer in college 4 years later, you get to learn why anyone would care about calculus, which is crazy. There's an old essay that I love, which was like, what if we taught music the same way we taught math? Which was, no kid ever gets to hear a song or like, play an instrument until they learn the scales and they learn how to read notes.
Right.
Like,
It'd be
every
terrible.
kid would hate music. You would never ever have a musician. But that's how we teach calculus. So
no doubt. Really well put. Well, Trevor, thank you so much for coming on and taking the time tonight. Where can people find your work? Where should we send people?
So depends what you want from me, but easiest way is just trevorklee.com, trevorklee.com. I've got links out to my other stuff. If you want to check out my really bare bones biotech company websites, highwayfarm.com, that's pharm.com. And then otherwise just Google me. I'm like super Googleable. As long as you spell my last name right, Klee, you will find me.
That's great. That's a good gift. Awesome. Well, thanks, Trevor. Really appreciate it.
All right. My pleasure. Thank you.
Thanks for listening. We'll be back next week with a new episode of Narratives.